Greetings, fellow scholars. Are you ready to talk about measures of center and distribution? In this scenario, we're going to do a lot of calculations. We're going to calculate measures of center, range, median, mean, quartiles, outliers, standard deviation, coefficient of variation, data distributions, and the probability under the curve. Most of these calculations lead to one of the other calculations. So you guys are going to find out that these are a lot of calculations, but it will not take us much work, especially since we get to use Excel. And in Excel, we're also going to build tables, scatter plots, trend line, box plots, and bell curves. So that's going to be a lot of neat stuff I'm going to show you how to do. For starting this scenario, I want to show you a scenario that we did that's very similar to the one we're about to do. This one was about Army recruits and mall shoppers, just like the one we're about to work on. But in this particular case, we're looking at heights, and the one that we're going to work on today is going to be body mass index. But again, they're very similar. So to start talking about this, we have done all of these calculations, which you guys are also going to do. I just want to take a moment to talk to you about what these different things mean. The mean, median, mean, standard deviation, coefficient of variation. When we talk about a standard deviation, this particular scenario was 9 Army recruits, and we noticed, this is the heights of these Army recruits, we noticed that the average difference between their heights was only 4 inches. That's what the standard deviation means. We took all of their heights, we did a bunch of math with all of those numbers, and we came out with the average height of those recruits. I'm sorry, the average difference between the heights was 4 inches. Then over here on the right, we took the same survey from 9 random mall shoppers. And we found that the average difference between the mall shoppers' heights was 14 inches. So that's quite a difference between 4 inches with the recruits and 14 with the mall shoppers. So when we talk about standard deviation, we are talking about how dense is the data. If you look at the Army recruits, you can see that this trend line, this is a trend line going through these dots, and the dots are called a scatter plot. The dots are very close to the trend line, aren't they? Well, over here on our mall shoppers, the dots are very far away from the trend line relative to the Army recruits. And you'll also notice that our axes are labeled the same from 0 to 100 on both of the charts. And then our coefficient of variation, over here our coefficient of variation is very small, it's 0.06. Where over here on the right, our coefficient of variation is 0.23. Coefficients of variation are very small numbers, and they actually measure a much more precise spread of the data. But again, you can see that the coefficient of variation for the Army recruits is much smaller than for the mall shoppers. So that's how our standard deviation and coefficient of variation measure spread of data, just like this trend line measures the spread of the data entries. Now, let's look at this. This is all the same information. We're still looking at all of the same stuff. We just looked at it in many different ways here. We looked at some quartiles, and we'll calculate our quartiles. The quartiles are the center of the data. Our median is the center of the data. And the mean, this is actually supposed to be, these are just backwards, which is perfectly fine. The Q1, this is the lower quartile. So you see how these are the lower data entries are smaller than these data entries up here. Our quartile 1 is the center of the lower data entries. Quartile 3 is the center of the upper data entries, and our median is just the center of the data. For this particular case, we had 9, so our median sat right smack in the middle and didn't have to share its value with anybody. But our Q3 and our Q1 did. They actually had to use, you can see here, we added together 75 plus 74 and divided by 2 to find the average of those two values. So that's how you find the Q1 and the Q3. And then over here again, we had the same situation with the mall shoppers finding our quartiles. So quartiles just measure the centers. The median is quartile 2, but we don't call it quartile 2. It's just understood that it's quartile 2. And then the lower quartile measures the lower set, and the upper quartile measures the upper set. Now, look at these box and whisker plots. Hopefully you can see a correlation between these box and whisker plots and the standard deviations. Our Army recruits, again, let's just double check our axes. This axis actually goes to 90, so I'm just going to change that real quick to 80. Don't worry. When we get to your Excel report, I will walk you through how to do that. But here, now you guys can really see that our axes are set the same, but right here, this one is very close together, and this one is much more spread apart. The box and whisker plot, this line in the middle here is our median. Our median here was 60. Our lowest data entry was 34, which is this line right down here. And then our upper data entry was 77. And you guys will see the same thing in your recruits over here. But then also another interesting thing is we'll use the mall shoppers just because it's a little bigger and easier to see, is our quartiles. Well, what do you see at the top of this box plot? The top is at 70. 70 was our Q1. And then what about down here at this bottom corner? You see, hopefully you can see that's about 47. So this is called our interquartile range, and our Q1 and our Q3 give that to us. And then these are called whiskers, and they represent the minimum value and the maximum value. So those are all about box and whisker plots. Now I am going to move on to show you guys about standard deviation. This is part of Module 2. We will do this later. We're going to just get a start on this now. We'll talk about z-scores and get more specific later on. But right here, what's happening is we have a bell-shaped curve. When we have a set of data, this particular set of data is for BMIs, we can see that the data is normally distributed because, you know, that's what the bell-shaped curve represents, a normally distributed set of data. So right here, we can see that within the first standard deviation, that's what a standard deviation is how far away is something from the mean. So if I go back over here to this other scenario, I can see that my standard deviation here was 4. So that means that my first standard deviation would be 4 more than the mean. So it would be about 76. You see that our mean here is 72? So come back over here, and here we see that our mean is recorded right in this column, and it is a mean of 27. Our standard deviation for this set of data was 6. You see that right up here? So that means that my first standard deviation is going to be the mean plus 6. So that's what we did right here. We got our first standard deviation is the mean plus 6. And then the second standard deviation is the mean plus 2 6s, right? Or the third one is the mean plus 3 6s, the mean plus 4 6s. When we move over to the other side of the mean, then we start subtracting 1 standard deviation, subtracting 2 standard deviations. And what happens when we have a normally distributed set of data, we can use this curve to check the probability under the curve. The probability that somebody's score is between the first standard deviation of 21.6 and the first standard deviation on the other side, which is 33.9, the probability that somebody's score is within that first standard deviation is 68.2. You see, it's 34.1% chance that somebody's score is between the mean and the first standard deviation on the left. And then it's 34.1% probability that someone's score lies between the mean and the first standard deviation on the right. So within the first standard deviation, there's a 68.2% chance that someone's score is within that range. Now, what we say when we look at our outer score is the probability of lying within the first 2 standard deviations, which we also call a confidence interval. The probability of being within 2 standard deviations is 95%. So you guys, let's just go ahead and quickly have a look here. I'm going to open up a new tab, bell-shaped curve. And here on my bell-shaped curve, let's see, let's just open one up here. Here's one. All of these calculations are always the same. It's between the first between the first standard deviation, we have 68.2% of the population. And then from there, we just keep adding from the next 2 standard deviations. We have, what's that, 68 plus 10 is 78, 88 plus 6 more. So you add all that up together and we get a 95% confidence interval between the first 2 standard deviations. Also, you guys can see all kinds of stuff. Here's another one. It reports it differently. 68% of the population lie within the first standard deviation. 95% of the population lie within the second standard deviation. And again, that's what we call a confidence interval. And then 99.7% of the population lie between the third standard deviations. So the bell-shaped curve is used when we have a set of data to measure the probability of somebody's score being within a certain range under that curve. All right, guys, I'm ready to jump into our Excel report here. So let's go ahead and open our report and open the document that goes along with that report. Here we are on, this is going to be scenario 4 in our module 1 for this course. We're going to study the measures of center by using the body mass index. This is basically the exact scenario we just looked at, but instead of heights, we're doing body mass index. So we're going to copy these 2 charts into Excel and this chart and create basically what you just looked at. Let's go ahead and get going. I am setting up my workspace so that I can have everything situated the way I need it. I will try to keep the Excel large, although it's difficult because I do need to stay pretty spread out on this report. All right, number 4, where did you go? Here we are, copy and paste the BMI columns. So I am going to copy these 2 columns. I don't think I can copy them one at a time. I tried, and this does not work. So I'm just gonna go ahead and do it this way because I already tried it and it didn't work. I had my fingers crossed and that did not help. All right, so I am going to start right about down here because I already know how this is all going to be set up. And then I am going to, I don't know if it's going to be easier to type these in or select them like this. I actually have a little, oh, that's not going to be too easy. I'm going to pause the video and type these in. Okay, so I got a little carried away and already boxed in my charts. I was talking and everything as though the video was going. So here we have both of your 2 charts, and that's what the instructions say here. Copy and paste the BMI columns on the right into the spreadsheet, and then separate the columns with a space in between for this chart below. So now we're going to go ahead and put this chart, I am going to put this chart right here. And it had 5 spaces, so I'm just going to go ahead and box it in right off the bat. And here I have the range. I have a piece of, I use a glue gun. I have it, it's actually right here next to my bed because, which is where I'm doing this work. And I use that glue gun. Every time one falls off, I have to put it back on, and it is for my keyboard. I have a little dot on my C and on a couple of other things like my 1 and my 0 and just different pieces that I need to find really easily. So it's easy for me to copy and paste. I can do it quickly because I have that little dot there. So if anybody likes that idea, it really works out good. All right, it looks like I did get one little extra space here, so I am just going to change, I don't know what to do there. I guess I'll just put no borders and then come back here and put a border again. Okay, now I have my range, median, mean, standard deviation, and coefficient of variation. And those are going to be, I'm going to have those for both of these. But before I copy this, I'm going to do some cool stuff. The next set in my directions says to separate the columns with a space in between to insert the following chart, and then use Excel formulas to calculate the measures of center. So that's what we're going to do right now. I'll make this as big as I can for as long as I can, folks, but don't get spoiled because I have to have it small later on in this scenario. My range, it says in those instructions that the range will be calculated in part foxtrot. So we're not going to calculate the range just yet, but you are going to be thrilled with this. Watch. Put an equal sign, type MED, double click on median, and then select your values over here and hit enter. Now for your mean, you're going to put the equal sign and type average, double click average, and again, just select those values and hit enter. How do you like that, guys? For my standard deviation, you press equal sign and press STDEV, and you get a lot of options here, so make sure you get the correct one. It is STDEV only. Lots of options. You see it? Double click. And again, select that data. Wow, very nice, folks. Folks not using a spreadsheet-based platform do have to use the formulas and actually calculate all of these. With a calculator, it's kind of hard. Excel's amazing. Now, the coefficient of variation is really, really, really complicated. You put an equal sign, and then you take your standard deviation, and you divide it by the mean. And there we have the coefficient of variation. A big, hard word for such a little, tiny task. All right, now I am going to select these data sets. I am going to come up here to my, move them. I'm going to move my decimals. I only want to have, let's take it to the hundredths place. Does that look good? Or maybe the thousandths, hundredths? Okay, we'll go to the thousandths place. So now, also, let's go ahead and I selected that. I'm holding my control button down on my keyboard and selecting the cell for Army recruits and the cell for mall shoppers. It never highlights the last thing you click, so that's why you guys can't see it. And then I am going to paint those, talking about military, so maybe we could use that drab green. Is that too dark? I don't know. That looks good. All right, but mall shoppers are green too, I guess, right? It's a green mall. Uses solar power. All right, so here we are with our data sets. Now you guys are going to love this. Are you ready? I'm going to select this entire chart, Control Charlie. Come over here, make sure it's in the same proximity. You see how the corners were touching? Just like so. Make sure the proximity is the same, and then Control Victor, and voila. What do you have there, folks? Check out your median over here. If I clicked this, it used that data set under the Army recruits, but my median over here used the same proximity and got my mall shoppers. And I just realized that I'm going to just change my mall shoppers to a different color. How about mall shoppers are orange? Orange kind of seems like a happy color. Maybe people in the mall are happy. Not me, if I was in the mall, I don't think. Okay, so let's keep rolling on here. We have all of this data. The next thing that we are going to do is select this set of data here, and then we are going to insert a scatter plot. Scatter plot, right up here at the top, insert a scatter plot. Very nice. And then inside of our scatter plot, we are going to add our axes titles. And we are also going to add down here a trend line. Very good. Remember when we did our PowerPoint presentation and I said we were going to calculate all this stuff and build scatter plots with trend lines? Isn't it crazy? It sounded like so much, but we just did it all in like, I don't even know how many minutes, but not many. All right, a couple of other things that we need to do here. Don't forget, I am not labeling all of these titles in my videos. You guys are responsible for that. When I go through and grade these, I'm really looking for those titles, and it really makes me look much deeper into your work when the titles are not on there, because then I have to actually open your Excel and click on it and stuff. So otherwise, I may just scroll through your Excel on the way you turn it in through your learning management system. But if stuff isn't titled and it starts looking off, then I'm going to download your Excel, put it on my computer, and actually start clicking on things. So you want to make sure your charts and your titles are all labeled so that you don't get nitpicked as bad. All right, so here we are now over here at our mall shoppers. And, also when you guys label these graphs, oh, I just want to try something. I'm going to delete this graph since I didn't really put much time and effort into it. And I don't think I selected where it said Army recruits. I'm not sure. Because I think if I did, yeah. If I select that, it will actually title that for me. So you guys be sure that you select that. And then over here on my mall shoppers, I am going to do the same thing, insert a scatter plot. And then I am going to give it some axes titles and add a trend line. All right, a couple of things that are not going great here are that I am going to take this top box if I can. I don't know. Sometimes I'm not able to get these boxes to move around. So I'm just going to do something. I don't know what. I'm going to pause this and see if I can figure it out. Okay, I figured it out. I did have to actually retype it. It would not let me. I just deleted it and then came up here and pasted it. I did not want this title taking up so much space. So because it was taking up so much space, I was not able, I won't be able to do some of the other things that I need to do. So that's why I have just changed the way the title was put up there. Okay, so now you guys, another thing that we need to look at, remember in our scenario about the bowlers and the unemployment rates, well, our axes on those charts had to start at 0. These both start at 0, but we're still not getting a clear picture of our data because the axes have different maximum values. So I'm going to click on this axes over here and change my maximum value to 80. And now I get a much better read on my data. So let's have a look here what we've got going on so far. I have, and just so you guys know, I'm just going to name this down here is the number of people. And then this is going to be the BMI scores. All right, now you guys can see here, you have, for this particular set of data, zoom this in and look at it a little more closely. We have a mean and a median that are almost the same, aren't they? They're very, very close to the same. Our standard deviation is only 3.4. That means that the difference between the BMIs for these, the average distance between the BMI data entries for these Army recruits is about 3.5. So that's a pretty low difference between BMI scores. Now the coefficient of variation is 0.2. Now let's look over here at our mall shoppers. Our mall shoppers have a standard deviation of 17. So their BMIs have an average difference of 17, which is pretty high. The mean and the median are not close. These values may seem close to you, but relative to these data entries, this is not close. And then our coefficient of variation is 1/2. And we can relate all of that to these dots. These dots are very tight about the trend line, and these dots are not. So we have differences in our data entries and the spread of the data. All right, you guys ready to keep on keeping on here? We are now going to select these two charts and paste them directly below here. I selected them both and pasted them that way. That's okay. I can, if yours happens to do that, you can just select it, get your weather vane cursor, and drag it over. Excel is marvelous. Now we are going to reorder these data sets. So I'm going to select just the data, not the words, just the numbers, and then come up here to sort and filter and arrange them from the largest to the smallest. Now you can see that I have the largest data set on the top and the smallest on the bottom. I'm going to do the same thing over here, sort it from the largest to the smallest. Now I'm going to mark my mean. So right here on my mean, I'm going to go ahead and mark that, or I meant to say median. And you guys just put an equal sign here and click on your median and you will get your median right there. Now I'm just curious, my median is 9.8 and up here Excel calculated my median as 9.8. I don't really need those decimals, do I? So whether Excel calculates it or you put it in order and just choose the center value, it's still your median. Pretty cool, isn't it? Now, what about our Q1 and our Q2? My upper quartile range comes from these two numbers right here, and my lower quartile range is going to be the average of those two numbers because that's the center of the upper and the center of the lower. So here I am going to select these two cells and I am going to merge them. And I am going to type in Q3. And I am going to merge these other two cells. And in this cell, I am going to type the sum of these two values. Just select those, close my parentheses, and divide by 2. So the sum of those two divided by 2. And you guys can see back here, whose was that? On Tinny's? Or no, back here. This is Abaza's. On Abaza's, she didn't do the sum command. She did something different. She did, whoops, where is it right here? She just added those two values together, you see? She just added those two numbers together and divided by 2. It's the same thing. I just wanted to show you that. All right, so back to our little task. I am going to select these two cells. I'm going to center them and paint them. And then I'm going to Control Charlie, come down here to these cells and Control Victor. And voila. A couple other things, I'm just going to select these cells. I'm holding down my Control key to select multiple different cells, and I'm going to put a border around those. All right, now I'm going to select all of these and Control Charlie. Uh-oh, wait, before I do that, this Q3 down here needs to be called Q1. And that, just to double check, it did use the sum of the right numbers because remember, Excel uses proximity. So let's see, I'm selecting all of this stuff, Control Charlie. I'm going to come over here and Control Victor it right in there. Pretty cool, right? Selecting all of this and changing it to our happy orange. And there we go. Oh, I also wanted to select these cells. There we go, folks. I now have a nice reading of my quartiles. My quartiles tell me how my data ranges. I can see that the center of my data is 19.8 and my first quartile is 23. There's not much difference between those two. A difference of 3. And then from my mean to my lower quartile is even a little bit less, isn't it? So that tells me that even the median is, you know, I have a little bit of a heavier set up here on my upper entries, doesn't it? Because it's, see how my mean is actually closer to the quartile 3 than it is to quartile 1. And you could just do some simple subtraction to calculate that. It's not much difference though. Barely any at all, really. All right, so over here, let's look at this. We have this section, you have a from 28 to 21. So you have a difference of about 7 from your median to your lower quartile range, but then your upper quartile range, holy cow, look how far up that is. It's not quite doubled, but you know, it's more than half as much, more than 10. So here you guys can see that our data is skewed much more upward to the upper half than the lowered. And we're going to look at that skewness here in just a second on our box and whiskers plot. Now, the next thing we're going to do is select this data, insert a more scatter charts down here at the bottom. Move your mouse around and then find box and whiskers. And you're going to insert a box and whiskers plot in there. All right, now we're going to do the same thing to the mall shopper data. Insert scatter plots, more scatter plot charts. Move your mouse around and find box and whisker and insert. Now, just like when we did our charts above, we do have to make sure that our axes are on the same page. So the axes for our mall shoppers is 80, and for our Army recruits is only at 30. So I am going to select that axis, come over here to my graph, and axis options, and I want my maximum value here to be 80. All right, and then you guys, of course, you are going to label your charts just like you did before. Everything needs to be labeled. You're going to add your, you don't need anything down here for your x-axis, can be left blank, but for your vertical axis, you are going to label that as BMI scores. I'm having a hard time deleting this. And there is a way to add just one axis title instead of 2. So you guys can have a look at how that goes. All right, we're not quite done. We have a thing to look at here. Do you see this little dot? Look at that little dot. What do you think that is? That is called an outlier. That means that the set of data, this data point, is more than, well, what we do to calculate outliers is we take Q3 minus Q1, and we get that difference. And then we multiply that number by 1.5, and then we add it to our entries, to our quartiles, and see if we have any outliers. So in this case, we don't have to do that because Excel did it for us. Because what if this was only, I don't know, what if this was only 70? If it was 70, it would not be an outlier. So if I took Q3 minus Q1, got the difference of that, multiplied it by 1.5 and added it to Q3, it would not be more than 70, but it would be more than 72.5. Once I hit 72.5, I had an outlier. So you guys can use your box and whisker plots to calculate outliers, and they are really helpful. Once you get an outlier, your data's skewed. Let's see, I do have some stuff here. I can actually show you another piece of skewed data that we're going to be looking at later on in the term. This right here is a set of skewed data. This is American income. And the average American income is way over on this lower end of incomes. The lowest ends is where the most people sit. But then these folks over here on this side make so much money or own so much money that they drag the data out to the side. Instead of having that nice normal bell-shaped curve that we see up here, when we have a big outlier like these super wealthy people over here create what we call a skewed data set. And once we get a skewed data set, we can't use all of our measures of center anymore. Our mean is way over somewhere that doesn't make any sense for the set of data. So that means that we're not able to use our data distribution entries. Like we have here, our standard deviation is 17. Well, that doesn't really make sense because our data just has this one huge BMI score that is making our standard deviation not be a true average difference. So sometimes you will find that scientists will throw out the outliers to find the average data set. Another cool thing that we're going to study later on, I'll just mention it real quick, is if we only took 9 mall shoppers here, if we would have taken 900 mall shoppers, we would have ended up with a normal distribution, because instead of just one person having that high BMI, we would have had many more with that BMI and then all in between. But we're going to look at that more later on. All right, our set of instructions, if I remember correctly, say to create a bell-shaped curve under the set of data that does not have any outliers. Well, that takes care of this, the random mall shoppers. Let's go ahead and paint that cell red. That is an outlier. So now we know we cannot use this set of data. We cannot use all of these measures anymore for this set of data. They don't make sense because our data is skewed. That outlier is really dragging our data to a place that makes our measures of center unusable. All right, let's have a look at how do we do a standard deviation notation. That's what I was thinking of. I'm going to actually come back over here to my chart and collect. Wow, look, we've already done all of that work. I'm going to collect this. I don't really know what to do here. I'll just collect the whole thing if I can. Maybe. I know it's not really that fun watching me sit here and clicking on this, and now it's not even going to work, even though I've got it selected. So Control Charlie. I am going to bring this. Now this is where I'm going to have to make this just a little small here to get us going. Well, I can actually make it big for this part. So I am going to paste this in here. It is not going to come out the way I want it to. So I know I've already tried it. But what I do also know is that I can just delete all of this stuff, Control X, and I'll just have that left in there. Now let me show you what happens when I hit enter. Excel thinks I'm trying to do some math because of that negative sign. And it's telling me, look, if you're not trying to do math, just put a little parenthesis, or I'm sorry, apostrophe before it, and we will know you're not doing math. So just do that. Now I am going to paste all that stuff that I cut out of the last one. You guys can do this however you want to. This is just how I think it's easier. I'm putting my apostrophe before each of the negative numbers because that's what Excel requires. And then I'm just going to Control X and then keep Control Victoring these right into the cells. Until I can get the chart the way I want it. I don't know. Can I do that? Nope. Just trying different things. I should have paused the video, but I'm almost done now. So we've just about got this figured out. All right, now we are going to go ahead and create a chart here. Let's go ahead and box this in. I am going to center everything, make it look nice. I'm going to make my standard deviations bold and even give them a little color. We'll keep with our green theme since we're still dealing with our recruits here. Now I need to get my standard deviations. This is where I'm going to have to go small on this. Or not my standard deviation and my mean. So I am just making this small because I'm going to have to click back and forth, but just for a second, and then I can stop. So for my mean, I'm going to put an equal sign and then go up here and select the mean and press enter. For the first standard deviation, I am going to select the mean again, and I'm sorry, I have to put an equal sign, select the mean, and then plus 1 standard deviation. And now I just selected my standard deviation and press enter. Now I can get big again here for you guys. All right, I am ready to calculate out these standard deviations. First of all, I know that my mean and my standard deviation are not going to change, so I am going to lock those in with a $sign around the letter part of the address. All right, now I am going to drag that over and just use it in every single cell. And then here in my second standard deviation, I'm just going to type in 2 times, that's the mean plus 2 standard deviations. Here I have, oh, I know what I want to do. I'm going to come back here and I'm going to copy that. Copy. And then here I can just paste that and just change my 2 to a 3. This is 3 standard deviations. And for the sake of our bell-shaped curve, we don't normally talk about 4 standard deviations away from the mean, but because it helps us build a prettier curve, we're going to use the 4th standard deviation there. All right, now I'm just going to control Charlie and control Victor, each of these pieces right into their corresponding left sides. Hopefully you know what I'm going to do next here. I am going to change these plus signs to minus signs. Make sure you press enter each time you do that. You can't just click into the next cell because it adds a reference. So be careful with that. All right, you just change each of these to minus and hit enter each time. I know with technology it's a love-hate relationship. It makes things easier and then it seems complicated. But if you guys ever in your life had to do all of these calculations by hand, you would just be loving the small aggravations of clicking around in Excel, especially with me showing you how to do all of this. All right, so the next thing I'm going to do is just double check my entries. My standard deviation for this one was what? 3.5. So I'm just going to check that these are each about 3.5 apart. Yes, 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 yes. And then these are lowering by about 3.5. And it looks like everything's good. All right, we're ready for the next part. I'm going to need more space above this chart. As you saw, I am going to insert a bell-shaped curve above. Oh, here's a different example. Here you see the chart with the curve above it. So that's what we're looking to do here. So give yourself a little room. I'm just going to select it and move it around with my weather vane. I only ever had it up there so I can reference my cells the way I needed to. Now, you see this first 6.3? Actually, I'm going to clean this up a little. I am going to get rid of some of these decimals. I think 1 decimal will be good enough. So 6.3 right here is the far left end of my standard deviation data set. And then 34 is the high end. So I'm going to create a chart over here that goes from 6.3. So I'm just going to reference that cell. And then I'm just going to go ahead and count by 2s. So let's see what happens. I'm going to put equals that number above plus 2. And I just need this to go to 34. Some data sets might require you to increase it by 0.01, or some might require you to increase it by 5,000. In this case, if I just increase it by 2, I should be able to get to where I want to be. Wait, what did I do here? Plus 2, that seems right. All right, so something went wrong. I'm not sure what, but I'm going to undo everything there. And so I have that number plus 2. Oh, I see. Because I did not need to select both of these, Excel got confused because I actually used this as a reference. So now I just drag just this one cell down. And there it went. I got it right to 34. So as long as I have some good set of numbers, at least 10, sometimes you need more, but because of the standard deviation being only 3.5, I can do this with a pretty small set. Now, the next thing you're going to do, go ahead and select 2 columns, that column you just created in another, and give them a border. And now I'm going to put equals normal, N-O-R, normal distribution. Double click that. And now you have your X value, which is 6.3. You have comma, you're going to do comma mean, comma standard deviation. So I'm going up here to collect my mean, comma, I just clicked comma, standard deviation. I'm going to come back down to my chart here. It got everything I needed, one more comma, and then you're always going to choose false in this class. False. All right, I'm going to lock these cells in, not the X, because I want that to change, but my mean and my standard deviation are going to be locked in because I'm about to drag this down and I definitely want it to change everything with the X values and keep the mean and the standard deviation the same. So I'm going to double click that. Now we've gotten some, what this did is it generated some random numbers of a normal distribution from the data entries that are here. So that's kind of cool. I am now going to select that set of data, both columns, and insert a smooth line curve. Pretty cool, right? Counting that 4th standard deviation is what gets us this little curve that comes out to the side right here. If not, it would have stopped right here at 30.6. So adding that 4th standard deviation is just kind of a keep our bell-shaped curve looking good in Excel. All right, now we are going to, you know, you don't have to set this right on top, but sometimes you can really get it to line up. And I try not to spend too much time trying to get it to line up, but it's hard because I want it to. All right, so our mean here is about 20, right? So my curve looks pretty good. My first standard deviation is about 23. And what we're going to do to really measure this is insert a shape. Where's shape? Insert, oh, I can't be clicked on this chart. See how I'm clicked on the chart? You have to click off the chart. Excel's so picky. Now I can insert an illustration, a shape, and I'm going to insert a rectangle, and I'm going to put my rectangle right about at the mean. Shape fill. And if you don't see shape fill, just right click and you'll see fill, and you can format, you can get to your shape fill all kinds of different ways. But mine happens to be right up here, so I'm going to use it. More colors, and you're going to make your transparency to about 50%. And change the color to anything that you like. All right, now I am going to set that right in the middle and try to measure it to my first standard deviation. Now, my axis down here, make sure these are labeled too, guys. Please label all your axes. That's really looking for a lot of things, but that's an easy thing for me to spot. Please make sure it's done. So here I have 20 to 23, but I can't see my 23. So I'm going to click my axis down here, and I am going to change my major. That means how much I'm counting by. I'm counting by 5s, but I really want to count by 1s so that I can see better. That's way too many decimals. That's why it looks so busy. So I'm going to go down here to my number on my axis format, and it says decimal places to 1, and I really don't want any decimal places. So I'm just going to put 0. Now it's nice and cleaned up, so I can see better. All right, that did actually also spread my chart out a little bit, so It makes me want to move everything around, but you don't have to. I just want to. All right, so now here on my 20, from 20 to what? About 23.6. So it looks like about there. And then this, if you guys Google, which you don't have to Google because I actually put it right here. It says notate the percentages. So you can just click on that and it will take you here to the percentages. And also you guys can read about it if you want to. Basically says everything I've told you plus a lot more detail. So here you see that each side from the mean to the first standard deviation is 34.1. So I'm just going to type that in here, 34.1. My text is white. I can't really see it because of the color I chose, so I'm going to change my text to black, and then I'm going to center it all around. All right, and this is not 43.1. What is it supposed to be? Is it 34? All right, so now I'm going to control copy and paste. And now the other one should be the same because it's always the same distance with normally distributed data, which this would not work for our setup here because of this outlier. We could force it to work by doing our normal distribution, but we won't because we already know it's a useless measurement because of that outlier. But for this set of data, it's the same on both sides of the mean. Remember how we discussed the upper quartile and the lower quartile were almost the same difference? Well, here we go from 20 to 16.7. So that looks about right there, about 16.7. Looks like we maybe should come in just a tiny bit more on each side. A little, I don't know. What was this one, 23.6? All right, so let's just keep rolling like we're doing. And then you guys are going to create another one of these things, change the color to whatever color you like, and you're going to change the percentage to what is the next percentage here. It is 13.6, you see? Control copy and paste, and there you have it. So our second standard deviation goes from about 23.6 to about 27.1. That looks pretty good, doesn't it? This one goes to about 13.3. They're a little off, but you know, that's, look at, I can even just move my whole graph and center it just perfect. So then you're going to do that again. Control Charlie, Control Victor, and we're going to go up to 3 standard deviations, change the color here. How about a nice, let's try a nice magenta. That looks good. All right, and this one is going to be labeled as 2.1. And then again, Control Charlie, Control Victor, and there you have it on the other side. All right, so now we can discuss that of our Army recruits, it looks like about 68.2% of those recruits have BMI scores between 16.7 and 23.6. You see how that works? So these, I can even paint these cells to match my standard deviations. That'd be kind of cool. These 2 cells were the yellow color, and then these 2 cells were our magenta that we created. Pretty cool. So now you guys can see if I wanted to know who has a BMI score above 23.6, then I can say, well, it looks like about 15.7 or so % of the population has a BMI score above that. One thing that I really wish I would have done here, you really have to do, and that's add these % signs. These are recorded in percents, and it is important that those are on there, so don't forget them. Too bad I didn't think about that before we copied all that. All right, guys, let's see where we are on this scenario. Doesn't this look great? Look at what you guys have done. Surely you're very proud of your work. Again, make sure everything's labeled, your axes title. If you need to if you need to move this chart around to make this, you know, just better in any way, you can just select all of this stuff. Well, I've kind of made a mess now, but you get the idea. You can move things around. Let's double check our instructions and see what all stuff we still need to do, if anything. But I don't think we do. We have added our bell-shaped curve. Now you guys are going to talk about these, make this 5-sentence report. And I've already discussed all of this stuff multiple times, so you should be able to very easily write that report. Hopefully you're reading the requirements of the 5-sentence report and, you know, paying attention to what you need to think about while I'm doing all the talking that I'm doing. All right, everybody, I guess that's it for this scenario. I will see you on the next scenario. Until then, keep being amazing. You rock. We rock.